In 1928, Frederick Griffith set out to find a cure against streptococcus pneumonia, also known as strep, but piqued Griffith's interest was due to the amount of soldiers dying in World War I at the time. The cause of their deaths was mostly due to this infection. In order for Griffith to conduct his experiment, he took two strands of the S pneumonia. The first was type S and the second was type R. The S colonies were known as the smooth colonies, whereas the R colonies appeared rough. Griffith experimented with 4 different trials using live mice as his subjects. The first mouse was injected with the R strain bacteria. Predictably, the mouse lived. This was because the R strain has no protective coat around it. Therefore, the R bacteria did not survive the mouse's immune system. The second mouse was injected with the S strain bacteria. Predictably, the mouse died. This is because the S bacteria has an outer coat known as a polysaccharide, which protects the bacteria against the mouse's immune system. The third mouse was injected with the S strand again, only this time the S strand was heat-killed. The results showed that the mouse lived. This was because the heating of the S bacteria caused it to become denatured. Therefore, the S bacteria strand was no longer deadly. The fourth mouse was injected with both the R strain bacteria and the S strain bacteria that was heat-killed. This resulted in the mouse dying. Even though the S strain bacteria was denatured by the heat, there were still active components in the S strand. The S strand was being consumed by the R strand, making it deadly. This process is known as genetic transformation. To conclude Griffith's experiment, his experiment proved that bacteria are capable of passing genetic information.